Our journey starts with console.log. It's the first tool we learn. It's simple, immediate, and perfect for a quick peek inside our code. For a single variable or a simple check, it does the job. However, this simplicity is also its greatest weakness. As our applications grow in complexity, relying solely on logging quickly becomes a significant bottleneck. Let's examine exactly why. The problem with console.log becomes obvious in a real application. You add one log, then another, and another. Soon, your terminal is flooded with messages, making it nearly impossible to trace the actual flow of data. Worse, you're constantly modifying your source code, adding and removing logs, which is slow, error-prone, and can lead to accidentally committing debug code. This chaos is a clear sign that we need a more powerful tool. So, what's the professional alternative? Node.js comes with a powerful built-in debugger that operates on a client-server model. Your Node.js application acts as the debug server, while a client, like Chrome DevTools, connects to it. This connection is made possible by the Chrome DevTools protocol, a standardized way for tools to instrument, inspect, and debug browsers and Node.js. This architecture is the foundation of all modern Node.js debugging. To activate this debug server, we use a simple command line flag, -inspect. When you run node-inspect your script.js, you're telling Node.js to start the application, but also to open a WebSocket server on a specific port, usually 9229, and listen for a client. Your code begins executing immediately, but the debugger is now active and ready for a client to connect and inspect it. But what if the bug occurs right at the start of your application? With -inspect, the script might run to completion before you even have a chance to connect the debugger. For this exact scenario, we have a crucial variation, -inspect-brk. This flag also enables the debug server, but it adds one critical behavior. It pauses execution on the very first line of your code, giving you all the time you need to connect your client before anything happens. Now that our application is running with the debugger listening, let's connect our client. The most accessible tool is the one you already have, Google Chrome. Simply open a new tab and navigate to the special address chrome://inspect. Chrome will automatically detect and list your running Node.js process. From there, a single click on the Inspect link will launch a dedicated DevTools window, fully connected to your Node.js application. Once connected, you'll see the Sources panel. This is your command center. On the left is the File Navigator, where you can browse your project's source code. In the center is the Code Editor, showing the content of the selected file. Most importantly, on the right is the Debugging pane. This pane is where the magic happens, containing tools like the call stack, scope, and watch panels. Let's start by learning how to tell our code where to pause. The most fundamental action in any debugger is setting a breakpoint. A breakpoint is a deliberate instruction for the debugger to pause execution at a specific line in your code. To set one, simply find the file and line you're interested in and click on the line number. A blue marker will appear. Now, when you run your code and the execution reaches this exact line, it will freeze, handing full control over to you. Once paused at a breakpoint, the real power of the debugger is revealed. You now have a toolbar to control the flow of execution. The Resume button lets the code run freely until it hits another breakpoint. The Step Over button executes the current line and moves to the next. Step Into dives inside any function call on the current line. And Step Out finishes the current function and returns to where it was called. We'll explore each of these, starting with the most common, Step Over. The Step Over command is your workhorse for line-by-line analysis. When paused, pressing Step Over executes the currently highlighted line and then immediately pauses on the next line within the same function. If the current line contains a function call, the debugger executes that function completely behind the scenes without taking you inside it. This lets you stay focused on the logic of the current function without getting sidetracked by implementation details of other functions. But what if you suspect the bug is inside the function on the current line? That's the perfect time to use step into. Instead of executing the function and moving on, step into navigates the debugger to the very first line inside the function being called. This allows you to trace the execution path down into deeper layers of your application, following the logic exactly as it runs. This is essential for understanding how different parts of your code interact. Sometimes you'll step into a function and quickly realize it's not where the problem lies. You don't need to tediously step through the rest of it. In this situation, use step out. This command will execute the remainder of the current function at full speed and then pause on the line immediately following the original function call, back in the previous context. It's a huge time saver for getting back on track. While your code is paused, the most critical task is understanding its current state. The Scope panel is your primary window into this information. It shows you all the variables and their values that are currently accessible. It's neatly organized into scopes: local for variables in the current function, closure for variables from outer functions, and global. You can expand objects and arrays to inspect their contents in real time, which is impossible with console.log. As you step through your code, especially after stepping into multiple functions, you might wonder, how did I get here? The Call Stack panel answers this perfectly. It acts like a breadcrumb trail, showing the chain of function calls that led to the current pause point. The function at the top is where you are now. The one below it is the function that called it, and so on. This is invaluable for understanding the execution path of your application. The Scope panel is great for seeing everything available, but sometimes you want to monitor a very specific value, like a deeply nested property or the result of a calculation. This is where the Watch panel shines. You can add any valid JavaScript expression to the Watch panel, and it will reevaluate and update every time you take a step or execution pauses. It's like having a persistent, powerful console.log that's always up to date. One of the most powerful features of debugging is the ability to interact with your paused application. The Console tab within the DevTools debugger is a live terminal connected directly to your Node.js process at its current paused state. You can type variable names to see their values, call functions, and even reassign variables on the fly to test different scenarios without ever restarting your script. This allows for incredible what-if analysis. Pausing on every iteration of a loop can be incredibly tedious. To handle this, we can use conditional breakpoints. By right-clicking a breakpoint, you can provide a JavaScript expression. Now, the debugger will only pause on that line if the expression evaluates to true. This is perfect for stopping on the 500th iteration of a loop, or only when a user with a specific ID is being processed, saving you a massive amount of time. What if you want the benefit of console.log, seeing a value at a certain point without pausing and without modifying your code? The answer is a log point. By right-clicking where you would set a breakpoint and choosing Add Log Point, you can enter an expression to be logged. When execution hits this line, the value is printed to the debug console, and the application continues running seamlessly. It's the perfect blend of logging and debugging. Instead of hunting for the source of an error, why not let the debugger find it for you? In the Sources panel, you can enable Pause on Exceptions. With this active, the debugger will automatically pause execution on the exact line where an unhandled error is thrown. This is incredibly powerful because it gives you the complete call stack and variable scope at the precise moment of failure, making the root cause much easier to identify. While Chrome DevTools is powerful, switching between your editor and the browser can be disruptive. This is why modern editors like Visual Studio Code offer an integrated debugging experience. VS Code has first-class support for Node.js, allowing you to set breakpoints, inspect variables, and control execution directly within the editor right next to your code. This seamless workflow can significantly boost your productivity. To start debugging in VS Code, you first need a launch configuration. This is a simple JSON file named launch.json, located in a .vs Code folder. This file tells VS Code how to start your application in debug mode. The most common configuration is launch program, where you specify your app's entry script. Once this is set up, you can start a full debugging session with a single click or by pressing F5. Besides launching a new process, VS Code can also attach its debugger to an application that is already running. This is extremely useful for debugging long-running services, applications started from a complex script, or processes running inside a Docker container. You would start your app from the terminal with Node.js Inspector, then use an attached configuration in VS Code to connect to it, giving you full debugging control without restarting the process. The VS Code debugging UI mirrors what we saw in Chrome DevTools, but integrates it smoothly into the editor. You'll find panels for variables, watch, call stack, and loaded scripts, typically in the Run and Debug sidebar. Breakpoints are managed directly in the editor's gutter. The floating debug toolbar provides the familiar controls for resuming, stepping over, into, and out of functions. It's a powerful and ergonomic setup for everyday development. Debugging asynchronous code like promises or async await used to be a nightmare with call stacks that made no sense. Modern debuggers, however, handle this beautifully. The debugger understands the await keyword. When you step over an awaited function, it correctly pauses on the next line after the promise resolves. The call stack is also async aware, showing the chain of asynchronous calls that led to your breakpoint, making complex flows easy to follow. Let's apply this to a real-world scenario: debugging an Express API endpoint. Imagine a /users/ID route is returning the wrong data. You can place a breakpoint at the start of the route handler. When a request hits the endpoint, execution will pause. You can then inspect rec.params.id to verify the input. Step over your database query and inspect the result before you send the response. This lets you pinpoint if the issue is with the input, the query, or the data transformation. Beyond finding functional bugs, the debugger is a gateway to performance analysis. Both Chrome DevTools and VS Code provide a CPU profiler. You can start recording, perform an action in your app, and stop recording to generate a detailed report. This report, often visualized as a flame graph, shows exactly which functions are consuming the most CPU time, allowing you to identify performance bottlenecks and focus your optimization efforts where they'll have the most impact. For long-running server applications, memory leaks can be a silent killer, causing your app to slow down and eventually crash. The debugger provides tools to investigate memory usage through heap snapshots. You can capture a snapshot of your application's memory at different points in time. By comparing these snapshots, the tool can reveal which objects have been allocated but never released by the garbage collector, pointing you directly to the source of a leak. Finally, let's review some best practices to make your debugging sessions effective. First, always have a reliable way to reproduce the bug. Second, isolate the problem by simplifying the scenario. Third, use the full power of your tools. Don't forget conditional breakpoints and watch expressions. Fourth, work backward from the incorrect output or error. And finally, always remember to remove your breakpoints and log points before committing your code. Congratulations! You've journeyed from the simple console.log to the precision of a professional debugger. You now have the skills to set breakpoints, control execution, inspect complex state, and even analyze performance in your Node.js applications. Practice these techniques regularly. They will not only make you faster at fixing bugs, but will give you a profoundly deeper understanding of how your code actually works. Happy debugging!